good evening in India, good morning in the United States. I suppose it's good afternoon in Europe. This is Peter Minnett. I'm giving this presentation on behalf of my co-authors, Jorge Vasquez and Edgar Armstrong from JPL, but of course there are many people from Rasmus, my institute, at NASA Goddard and at JPL involved in producing sea surface temperatures from MODIS. As we know, MODIS is a 36-channel high resolution or moderate resolution, 1 kilometer in the infrared channels at the subsurface point. And 2 versions fly on Terra and Aqua. And they have been flying for over 20 years. So they have been producing sea surface temperatures for the whole duration of GHRSST. There are 2 sets of infrared channels for the generation of sea surface temperature on each MODIS. There's the regular split windows for the NLSST, but the half widths of the channels are about 0.5 micron, whereas in most radiometers they're 1 micron. And there's a slight modification to the nonlinear sea surface temperature algorithm to match the MODIS instrument characteristics. There's also a second set, which is referred to, or the product is referred to as SST4, and it's based on 2 measurements of brightness temperature centered at 3.95 and 4.05 microns wavelength. And the table on the right shows the statistics of comparisons with IQAM buoys. This is just a simple comparison, and also ship radiometers, primarily our instruments, the MURs. And the ship radiometers are withheld data sets, so they're totally independent of the derivation of the SSTs. The SST4 has much less scatter than the NLSST, but because of solar contamination, as everyone knows, it can only be used at night. So what we see here on the left are the box whisker points, plots for monthly comparisons with IQAM data. And they're in latitude bands starting at the bottom south of 40 degrees south, then 20 to 40 degrees south, equator to 20 degrees south, equator to 20 degrees north, and so on. And the fidelity of the data compared to the drifters is very, very stable over the full 20 years and more of the Terra MODIS mission shown here. Aqua MODIS looks very, very similar. On the right, we have box whisker plots for the angular dependence of the satellite zenith angle. And this is for SST4 versus buoy data. And we see that while the variance increases with longer atmospheric path lengths, i.e. larger satellite zenith angles, the median value is essentially constant. Somebody's echo. Can I talk now without an echo? Yes, I can. Good.
Please go ahead. Yes.
Yeah, thank you. The red line is the canonical value of the mean thermal skin effect at -0.17, and the fact that we have an offset here and throughout implies that that value has to be or should be revisited. So both Terra and Aqua were put into maintained orbits, which means that the orbits repeat every 3 days and the sub-satellite tracks are within 1 kilometer of each other. This requires quite a large number of maneuvers in the orbit to maintain that repeatability. That consumes power. And the source of that power, the rocket fuel, is now getting depleted. So the satellites are being allowed to drift. Terra is moving earlier in the day and Aqua is moving later in the day. This means ultimately the missions will come to an end because the solar radiation incident on the solar panels is varying from the design values. So here on the left, we have the time projection of the equator crossing time for Terra moving earlier in the day, and on the right, Aqua moving later in the day. So sometime around about 2026, it is presumed that the power budget of the spacecraft will require instruments to be switched off. So we don't want to lose the 2 decades and more time series of MODIS SSTs. So what are the candidate missions to continue the data? And for Aqua, which has a 1:30 equator crossing time when it was in a maintained orbit, the successor is fairly clear. It's the VIIRS on SUMI NPP, now NOAA 20 and 21. Same equator crossing times in slightly different orbits due to a higher altitude, which means there's not a one-to-one correspondence in the measurements, but the wide swath gives global daily coverage both day and night. The infrared bands on VIIRS are a subset of those on MODIS, which means there isn't a possibility of an SST4, which is somewhat unfortunate, but nevertheless, a triple window using 11, 12, and 3.7 micron data from VIIRS seems to be very good. Data are now available, SSTs from SNPP VIIRS, and I think maybe NOAA 20 VIIRS are available from the OBDAC at Goddard and also from the PODAC. The successor missions will carry on the VIIRS time series to beyond 2039. At least that is what is planned. The successor missions for Terra MODIS are less obvious since there is no current or planned US polar orbiter flying in a 10:30 equator crossing time orbit, but there are some candidates from Europe which could work. Currently, there's the AVHR-3 on METOP B and C in a 9:30 descending node orbit with a broad swath. B will probably be decommissioned ahead of MODIS, unless something terrible happens to MODIS, but C could, AVHRR on METOP C could continue. Of course, there's the SLSTRs on Sentinel-3A through to 3D, 10 o'clock descending node orbit, but they have a narrower swath, but they will have a long time series. Looking to the future, MET image on METOP second generation A1 will have a 9 o'clock descending node orbit and a broad swath image. So for now, if MODIS were to, on Terra were to fail catastrophically, then the SLSTRs would probably be the best sensor to carry on the time series. In the future, MET image, first one to be launched in the first quarter of 2025 would be the best options. But why do we want to worry about continuing the time series? Well, there are many reasons, but one of them is that it's the basis of MUR, the multi-scale ultra-high resolution SST dataset that is produced at NASA JPL in the PODAC. And recent improvements or developments have been to produce MUR using data from the cloud, the AWS cloud at the PODAC. It's a gridded product with 1 kilometer resolution, and it's very, very popular. It's widely used, 2,500 unique users in a given year, typically. It's also the basis of the State of the Ocean Worldview, which is an image browser that is also very widely used. And it's also a key layer in the recent NASA Earth Information Center, which is a public outreach exercise in the foyer of NASA headquarters. So I'm told. I haven't been to see it yet. So the prospects for MUR continuity are to take L2s from continuing from MODIS and then to successor instruments using cloud computing. This involves quite a bit of work and there is an element of risk, but we hope it is all manageable. So, to summarize, both MODISs have contributed over 2 decades of high-quality, high-resolution skin sea surface temperatures. The MODIS SST skin temperatures are the basis of MUR, one of the widest used data sets downloaded from the PODAC. The MODIS SST skin time series, there's no avoiding it, they will come to an end in the next few years. Successor instruments for the Aqua MODIS are the VIIRS, and there are options for the Terra MODIS, but while they have been identified, we will have to work out how best to go forwards with that. And it is likely that MUR will be extended with VIIRS data. Thank you.